In 4 years, something impossible is going to happen. An asteroid the size of the Empire State Building will pass so close to Earth that you'll be able to see it with your naked eye as it tears across the night sky. So close that it will fly beneath our satellites. So close that if its path shifted by just a fraction of a degree, it would hit us with the force of 1,000 nuclear bombs. They named it after the Egyptian god of chaos, and in 2029, Apophis is coming for us. For over 15 years, astronomers have been tracking this 340-meter-wide mountain of rock hurtling through space at 30 kilometers per second. When it was first discovered in 2004, scientists calculated a terrifying probability. Apophis had a nearly 3% chance of hitting Earth in 2029. 3% might not sound like much, but in asteroid terms, that's catastrophic. That's the highest impact probability ever assigned to an object of this size. To put this in perspective, an asteroid just 340 meters across wouldn't cause global extinction, but it could absolutely devastate an entire region. The Tunguska event in 1908 flattened 2,000 square kilometers of Siberian forest, and that object was only about 50 meters across. Apophis is nearly 7 times larger. The Chelyabinsk meteor that exploded over Russia in 2013, injuring over 1,500 people, was only about 20 meters in diameter. Apophis dwarfs it completely. Fortunately, after years of observations, scientists have confirmed that Apophis will miss us in 2029. But here's where the story gets interesting. It's going to pass so close that Earth's gravity might fundamentally change this asteroid forever. And that change could determine whether it becomes a threat in the future. On April 13, 2029, Apophis will come within approximately 32,000 kilometers of Earth's surface. To understand how close that really is, consider this. Our geostationary satellites orbit at about 36,000 kilometers above Earth. Apophis will pass closer to us than the satellites that bring you GPS, weather forecasts, and global communications. It will be so close that people across Europe, Africa, and Asia will be able to look up and watch it streak across the sky with the naked eye. No telescope needed. NASA and the European Space Agency have confirmed that we're safe from impact for at least the next 100 years. But what happens during that close pass is anything but certain. When an object the size of Apophis gets this close to Earth, our planet's gravitational field doesn't just pull on it gently, it squeezes it, warps it, potentially reshapes it entirely. Scientists believe Apophis is what's called a rubble pile asteroid. It's not a solid chunk of rock. It's more like a loose collection of boulders, gravel, and dust held together by weak gravity. The tidal forces could trigger landslides on Apophis. They could cause the surface to crack. They could even change its rotation. And here's the critical part. If the shape or rotation of an asteroid changes, its trajectory through space can change too. A tiny shift today could mean a collision decades from now. This is why the European Space Agency is launching one of the most ambitious planetary defense missions in history. It's called Ramses, the Rapid Apophis Mission for space safety. Ramses is going to meet Apophis before the flyby, watch it pass Earth in real time, and document exactly what happens when a planet's gravity reshapes an asteroid. Ramses is scheduled to launch in 2028. It will arrive at Apophis in February 2029, giving it about 2 months to study the asteroid in its natural state. Scientists will map every crater, every boulder, every surface feature. They'll measure its exact rotation rate, its shape, its structure. Think of it as the before photo. Then, on April 13th, Ramses will have a front row seat to one of the most spectacular celestial events in modern history. As Apophis passes through Earth's gravitational field, Ramses will watch for any changes. Cracks forming in the surface, boulders shifting position, alterations in the spin rate. It will capture the after photo, documenting how Earth's gravity has transformed the asteroid. This data isn't just scientifically fascinating, it could be life-saving. Because if Apophis, or any other asteroid, ever does come back on a collision course, we need to know exactly how these objects behave when they're subjected to intense gravitational forces. We need to know if they're solid or fragile. We need to know if they'll break apart or hold together. And most importantly, we need to know if our attempts to deflect them will work. The Ramses mission is part of ESA's Space Safety Program, a coordinated effort to protect Earth from cosmic threats. Ramses will carry 2 CubeSats, small companion spacecraft that will deploy to study the dust environment around the asteroid and potentially detect seismic activity as Earth's gravity stresses the interior. Japan's space agency, JAXA, is involved as well, with discussions about launching Ramses aboard Japan's H-3 rocket. This is planetary defense going international. When Apophis enters Earth's gravitational sphere of influence, the forces acting on it will be immense. Scientists predict that the tidal stress could be strong enough to cause what's called seismic shaking inside the asteroid. Essentially, Apophis might experience its own version of earthquakes as it passes by. If the asteroid is indeed a loosely bound rubble pile, this shaking could cause internal rearrangement. Boulders could settle into new positions, and on the surface, we might see actual landslides. Ramses will have instruments sensitive enough to detect these tiny movements, watching an asteroid's surface in real time as a planet reshapes it. This has never been observed before. Every previous asteroid mission has studied asteroids that are relatively stable, far from any massive gravitational influences. Apophis in 2029 will be in a gravitational maelstrom, and Ramses will document every second of it. On the evening of April 13th, as Apophis makes its closest approach, it will be visible as a point of light moving across the sky. It won't look like a blazing fireball. It will appear as a star-like point moving slowly against the background of fixed stars. But what makes it extraordinary is that this star is actually a 340-meter rock passing closer to you than many of the satellites above your head right now. The flyby will be visible across Europe, Africa, and Western Asia. Amateur astronomers with even modest telescopes will be able to see it clearly. This will be the most observed asteroid encounter in human history. Billions of people will know it's happening. Social media will explode with photos and videos. News networks will broadcast live coverage. It will be a planetary moment, a reminder that we live in a dynamic solar system where massive objects occasionally pass uncomfortably close to our fragile world. Ground-based radar facilities will bounce signals off Apophis, creating detailed 3D maps of its surface. Optical telescopes will measure how sunlight reflects off different parts of the asteroid. And Ramses will tie all of this together with close-up observations that ground-based instruments simply can't match. But Ramses won't be alone at Apophis. NASA is also sending a spacecraft, and it has a very personal connection to another famous asteroid mission. In 2016, NASA launched OSIRIS-APEX, a spacecraft designed to visit the asteroid Bennu, collect a sample from its surface, and return that sample to Earth. That mission was a spectacular success. In September 2023, OSIRIS-REx dropped off its precious cargo, rocks and dust from an asteroid. But the spacecraft itself was still in excellent condition after completing its primary mission. So NASA gave it a new target. OSIRIS-REx has been renamed OSIRIS-APEX, the apex standing for Apophis Explorer, and it's already on its way. OSIRIS-APEX will arrive at Apophis shortly after the April 2029 flyby. While Ramses will document the before and during, OSIRIS-APEX will focus on the after. It will study the asteroid in its post-flyby state, looking for changes that might have occurred during the close encounter with Earth. Did the surface change? Did boulders move? Did the rotation rate shift? OSIRIS-APEX will spend months investigating these questions, and it has another trick. OSIRIS-APEX can perform a close flyby where it fires its thrusters while passing just meters above the asteroid's surface. The thruster exhaust will kick up dust and loose material, revealing what lies beneath the surface layer. It's essentially giving Apophis a gentle sandblasting. This technique was tested at Bennu, and it revealed pristine material that had been protected from space weathering. At Apophis, it could show scientists whether Earth's tidal forces have disturbed the subsurface layers. So we have 2 spacecraft from 2 different space agencies converging on one asteroid to study one event from multiple perspectives. And it's not just ESA and NASA. JAXA is contributing as well, potentially providing launch services and collaborating on instrumentation. When Apophis passes Earth in 2029, It will be a truly global scientific moment. Let's be very clear about something. Apophis is not going to hit us in 2029. We know this with certainty, but the reason we're studying it so intensely is because someday, an asteroid will be on a collision course with Earth. And when that day comes, we need to know exactly what to do. In September 2022, NASA successfully completed the DART mission, the Double Asteroid Redirection Test. DART deliberately crashed into a small asteroid moon called Dimorphos to see if the impact could change its orbit. It worked. The impact altered Dimorphos's orbital period by about 33 minutes, far exceeding expectations. That was humanity's first successful demonstration of asteroid deflection technology. But DART targeted a very small object, only about 160 meters across, and it was a moon orbiting another asteroid. Apophis is larger and more complex. The data from Ramses and OSIRIS-APEX will help scientists understand whether the same deflection techniques would work on a rubble pile asteroid like Apophis. If an asteroid is a loose collection of rocks, hitting it with a spacecraft might not deflect it cleanly. It might just break it apart, turning one threat into many. Or it might work perfectly, nudging the entire mass onto a safe trajectory. We don't know yet, but we're going to learn. ESA is also planning a follow-up mission to DART called Hera, which will arrive at Dimorphos in late 2026 to study the aftermath of the impact in detail. Together, DART, Hera, Ramses, and OSIRIS-APEX are building a comprehensive planetary defense knowledge base. We're learning how to track asteroids, how to characterize them, and how to deflect them if necessary. This is no longer science fiction. This is operational planetary defense. For most of human history, we've been at the mercy of the cosmos. Asteroids struck without warning. The asteroid that killed the dinosaurs 66 million years ago? They never saw it coming. But we're different. We have the technology to see these threats approaching, and increasingly we have the capability to do something about them. So let's walk through the timeline of what's about to unfold. In 2028, Ramses will launch, likely aboard an Ariane 6 rocket, or possibly Japan's H-3 rocket. It will begin its journey to intercept Apophis, carrying the mission objectives of ESA's Space Safety Program. By February 2029, Ramses will arrive at the asteroid and begin its initial observations. For the next 2 months, it will map every detail of Apophis's surface, measuring its shape, rotation, and composition. Meanwhile, OSIRIS-APEX will be en route, preparing for its own arrival after the flyby. And then comes April 13th, 2029. As Apophis approaches Earth, telescopes around the world will track its progress. Social media will light up with anticipation. And in orbit around the asteroid, Ramses will record everything. The close approach will last only a few hours, but in that time, Earth's gravity will exert forces on Apophis that it hasn't experienced in millions of years. Ramses will watch for surface changes, internal shifting, and any alteration to the asteroid's trajectory. And as Apophis swings past and begins to recede, OSIRIS-APEX will be closing in. Over the following weeks and months, both spacecraft will continue their observations, building a complete picture of how the encounter affected the asteroid. This data will be analyzed by scientists around the world and used to refine planetary defense strategies for decades to come. But beyond the science, there's something profoundly human about this moment. Apophis is not our enemy, it's our teacher. It's giving us the opportunity to learn, to prepare, to prove that when the universe throws a cosmic threat our way, humanity can rise to meet it. On April 13th, 2029, when billions of people look up and see that point of light moving across the sky, it will be a reminder that we live on a small planet in a vast and sometimes dangerous universe. But it will also be a reminder of something else, that we're watching, we're learning, and we're ready. The sky isn't trying to kill us. It's challenging us to be worthy of our place in it. And for the first time in history, we're accepting that challenge. Because the next time an asteroid comes for Earth, we won't just be looking up in fear, we'll be looking up with a plan. Thanks for watching. If you enjoyed this video, make sure to like, subscribe, and hit the bell for more space stories.